nice to see you all. My name is Michail. I work for JetBrains. I lead language design at Kotlin. And today we are going to talk about rich errors. And what are rich errors? I've briefly talked about this during the keynote, but just for those who missed it and going to watch online, rich errors is a new language features that we are developing today in Kotlin. And on the one hand, it generalizes this concept of nulls as errors. On the other hand, it kind of provides built-in support for types like result, either, optional, and so on. Plus, it gives the ergonomics of nullable types for chain calls and shortcuts. And today we are going to talk about this feature. And we'll start with a short story about the exceptions and other approaches that today we know, like in the hierarchy system and others. Then we'll talk about rich errors, syntax and semantics, and how it works with chain calls and shortcuts. And basically, today we are going to talk about error models. And I find these two questions one of the most important ones when those that can help us to focus on this topic. And the first one is like, how can I, as a developer, can express that a method might fail? And if a method might fail, how can I handle errors? And if we think about these questions, and especially if you've been programming like on the JVM platform, like in Kotlin or Java, then probably one of the first answers that comes to your mind is like, well, it's exceptions. But before exceptions, I'd like to briefly highlight how it works in C, which predates this approach for exceptions. And in C, it's just the approach is very minimalistic. We just use error codes when you want to signal that something is wrong. We have to not to forget to process it and then also return some other error code. And there are a few problems here. First of all, is that there's no type safety, just like an int, as a regular type. And it's also one of the main problems here that it's really easy to forget to check for errors, especially in native world. When if you miss an important error, your program can crash with a horrible, horrible error. And plus, there's no ergonomics for nested calls, and the situation can get quite messy. And Java, actually, they set an honorable goal to eliminate this problem. They wanted to make this processing of errors more explicit. And so, checked exceptions appeared in Java. And if you just take a look at this signature, it's actually quite nice. It's answers our first question about how can I express that a method might fail pretty nicely. But there are some problems started with the second question and also the approach that they took. For instance, here we know that often we cannot do anything meaningful with the exceptions. And also it's a boilerplate because I have to write always try and catch and also rethrow the exception. Well, it's not that useful. Of course, I can rethrow an exception and propagate it further to other call. But the problem begins when with lambdas and higher order functions, because in higher order functions there's no way to propagate this exception through your method. Because this lambda, for instance, in the for each expression, it executes somewhere else, not actually in the method of the usage. So we cannot rethrow the exception that comes from read file. And that's, in Java, we are forced to use try-catch blocks every time if you have a method that throws in the lambda. And that's a problem. And just to quickly if you want to phrase what's good and what's bad about Java exception is that they actually force developers to handle errors explicitly, and that's a good thing sometimes. And they also make code more robust to preventing silent failures, and that's also good. It's the thing that we will also love to solve. But however, in practice, we see that exceptions in Java they don't compose well with higher order functions, and also the other problem is that checked exceptions, they are part of regular exceptions or unchecked ones. And they have a few limitations or features. For instance, exceptions, they use non-trivial control flow. And if you throw an exception, well, who knows where the execution will continue. Maybe someone will catch it, maybe not. And it was more or less fine, like maybe 20, 30 years ago, when we used to write like sequential code and like with fail-first behavior. But now in the asynchronous world, when you throw an exception, well, something can go wrong. And also because checked exceptions are part of the unchecked story, there is like a huge room like for misuse. Even though like even in such libraries like JDK, Spring, and so on. And time showed that people started to get away from checked exceptions and rewrite their libraries to use only unchecked ones. And Kotlin, being like a successor of Java and originally being a JVM programming language, it inherited the concept of exceptions. But we knew all that problems, so we decided that checked exceptions shouldn't be a thing, and we have only unchecked ones. And that's interesting that unchecked exceptions have become like a separate feature that have their different use cases. And yeah, and what we are interested in today is that the lack of language support and like checked exceptions and other mechanisms in our language has led to various organic approaches to error handling. Because, well, we do not have like a built-in support to work with errors. I like do not have like a proper way to signal that my method might fail, which means that I have to be creative and do something else. And let's see what do we have right now, like what do we have like in Kotlin and what do we have like in other ecosystems. And we'll be using like a very simple example, like a two example, where we have just like two functions that they return JSON, and the other function that takes this JSON tries to do something with that. And the first approach that we have today in Kotlin is just to use nullable types. We can use nulls that they can indicate that there is some error. And what can we do with those functions? Well, first of all, we can use like them as a chain call using like safe call operator. We can try to invoke properties, but the compiler will prevent us because it's a nullable type, and we have to do like some ceremony to check for null, and so on. And if you break down this, so what do we like about this? The first thing is that it's really nice to do chain calls, because we don't have to like invoke a method, check for null, then do a method, invoke a method, check for null, and so on. The next thing is that we get like type safety. That's really nice and one of the core features in Kotlin. And also, the other feature that is at the heart of the Kotlin is smart casts. And nullable types and float typing plays really nice with smart cast, because if you check for null, we don't need like any pattern magic and so on. The compiler will know that the type is non-nullable. But however, it's not that ideal, because here we do not know like we reuse null for different purposes. Like first, we don't know like whether it's null comes from fetch user or parse user, and in some cases we do not know. We don't have like to need about this, but if we want, then we have like a tiny problem. And what can we do without this? Well, first of all, we can try to use like more types, because like if we reused like values for the same types, we can like introduce more types and be happy. So for instance, we can have like our original functions as nullable that return nullable types, and introduce like a separate seal hierarchy that will encapsulate this successful result and a bunch of like error ones. And now our function getUser that used to do like a simple chain call now invokes these two functions and returns this encapsulated result. And now that we can have at our usage all information about the potential errors. And that works to some extent, because it approach also have like a few disadvantages. Because first of all, we now have some problems with extensibility, because we decoupled our original functions from errors. Because what happens if I change my like fetch user or parse user like somehow? I have to remember now that I have to update my getUser shield function and so on. We now do not have the ability to do chain calls, so we have to do this classic pattern when we invoke a function, do something about the error, and go on. And plus, we do not utilize our smart cast, and we get this nesting before we can actually get access to the properties of successful result. And what happens again if you want to add even a bit more extensibility? What if we just want to introduce one more error case to our functions? Well, in this case, we can introduce even more types, right? And now we can want to fight this issue with decoupling and say that we have my function fetch user now returns a sealed hierarchy, and my function parse user also returns a sealed hierarchy. And that becomes messy. That's a fine way, but that can be quite hairy when it comes to usage. And if you think about this even more, if you write the same sealed hierarchies where we have this successful result and a bunch of errors, why don't we just abstract these things and introduce a generic version like result or either or something else? Well, let's try to do this with result, where it's just, again, it's a regular sealed hierarchy, but this time it's a generic one. It has a class success that just holds a value of t, and a failure that holds some value of throwable. And now we can use, the first thing here is that now we can use it just regular values. If you want to signal that something went wrong, we return a result of a failure class. That's easy. But now when it comes to usages, we have to use fetch user result, do some functional operators, and if it's successful, then return it. Otherwise, you have to rewrap it and return a failure. So what do we get here? First of all, we actually now get our extensibility. And it's relatively easy to add new error cases, and because results are all the same in your application code, you do not have to introduce new and new operators. They are all the same inside your project. But of course, on the other side, now we have huge verbosity. We have to remember how to use functional operators, because on success, on failure, runCatching, map, fault, and so on. And also because we capture just a single value, throwable. We don't know anything about all the potential errors, because and our when we want to process errors is non-exhaustive. So it doesn't allow us to write a bulletproof code when we want this. And I want just to remind you the original example that we used in the beginning. It's just basically what we are doing is that we are invoking two functions and trying to get the result, and that's it. And here's what we get when we want to write a bulletproof code. And yeah, and that reminds me of this classic meme that when we have nullable types, everything is fine. But once we want to add just a tiny bit of information to our result type, it becomes increasingly hard. And it means that there's a huge gap between nullable types and just more typed system, which means that there should be something else. We should have some capability, and we have to either in the type system or in the language. So, and this is a work in progress, and this is how we think we can close this gap and make the Kotlin safer. So let's take one more time, take a look at this example and how we can approach it with rich errors that are in the experimental right now in Kotlin. So first of all, we declare two error classes, network error and parsing error. These are marked with special modifier error, which is going to be a new one. Then our functions, instead of returning nulls or sealed hierarchies, they return a proper object like JSON or user. But instead of returning nulls, they return just error classifiers, network error or parsing error. And our function getUser that used to combine these two functions can now return user or these two errors. So it's a new syntax for declaring these union types with errors. And because it's just a regular type, we can abstract it and put it into a tape ls and say that now user error is just like network error or parsing error. And what happens with at the call side? So we can implement our get user the same as before. We can use like invoke the fetch user, use a save call, and invoke the function parse user. And in the function usage, we still cannot access the name while it's like highlighted properly, like with the semantic highlighting. At the same time, we can check if it's not a user, then it means that it's an error. We can like return and report that some error happened. And then the compiler automatically can cast, because it's not a user, and we write a return there, it can automatically cast to the type user afterwards. And we don't have to use any nesting and unwrap value. So same as with nullable types, we can write ergonomic chain calls. We have still type safety, and we have conciseness. So we can utilize like the core features of Kotlin and bring more types to the type system. And of course, we started that it was unclear what happens with errors, because like previously I had just null, but this time, because we bring more types, we can actually check all the types and get an exhaustive one like over the errors. So we also get like, we can still continue working like as with nulls, but if we need more errors at some point, we can process and report to the user everything what we want. And probably the first question that you have is like, this like, it looks like union types. You use like even the same like syntax for them. Is it like finally union types? Well, actually not really. The key part here that it's like makes this feature like distinct from the other ones, that here we have like the main actor, which is like user or like some other object, and a bunch of error attributes. And it's not possible to have like two actors. The actor should be always like a single one. But we can have like a bunch of error attributes that we introduce to the language. So we still do not allow to write int or string. So sorry for web developers, but it actually will be beneficial, as we'll see later. Because one of the outcomes here is that now like our compiler and our IDE can work better, because like same as with nullable types, if you like invoke a function that returns like nullable int, you can still like inspect the methods that you can call on an int, right? And here it's the same. When you invoke the function getUser, you can actually inspect what can you do with that. Because it's just we know that these are the methods that you probably would love to call. And that's not possible, for instance, with the types with optional, with results, because when you have just a result, you can invoke methods that are available on the result type, not on the main type, and which you're interested in. So that was an overview of the feature, and now let's dive into the design principles of it. And the first design principle is that errors work as values. We do not want to have like any special rules for control flow. That actually happens with exceptions. Because as we've seen, like one of the disadvantages of exceptions is that they use this quite like hidden control flow, and it's hard to tell where the execution of the program will continue. When errors are regular values, there's nothing. You just return them as regular objects. You work with them as with regular objects. They won't like interfere with your control flow and understanding of the program. The next crucial principle is that errors are designed for recoverable cases. Because here we actually want to draw a line with unchecked exceptions, or just exceptions in Kotlin, and cases for recoverable situations. For instance, here, when we want to just introduce like ad hoc like type system checks, for instance, I want to use my string, but have a few requirements that it's not empty, it starts with a letter. It's actually a great case for using exceptions, because normally I cannot recover from such a situation if I pass like a wrong string. What I'm going to do this? Probably the same as with checked exceptions. I will just rethrow the exception. And that's why it's fine to use exceptions here, but not errors. And also, if you remember if you know, like, and you visit our utrack issue in Kotlin, one of the most upvoted issues today is that that people ask is to introduce multi-catch block in Kotlin. And we are always saying that, well, we are not going to do this because we believe it's wrong to use exceptions and so on, and it's still true. But for me, it shows that this like strong signal that people still use exceptions for errors, and there is like deep need like in using like something like to signal that my method might fail, and that's why I like, want to catch it and do something convenient with it at the call site. And again, we are not introducing multi-catch, but with recoverable errors, when you actually want to handle them and want you to catch them, you'll be able to use regular Kotlin constructions like when and exhaustive fence and smartest and so on. So the next design principle is that we believe that exhaustiveness is crucial. So when we want to write a bulletproof code, the compiler should help you. And it will help you to understand the exhaustive set of potential errors, so errors won't slip by, and you'll be able to fix everything you want. And last, but not, it's not last. And one of the points that and things that we learned from the other ecosystems, and again, checked exceptions, that people want to write as short code as possible sometimes. And they want to like invoke like a bunch of methods like separately. They want to like do like chain calls, and it's important to introduce shortcuts when you work with the feature as well. It shouldn't be like the barrier, because otherwise, every time you introduce an error, you'll think twice whether, well, now all my clients have to struggle, and maybe I shouldn't do this. So that's why we are also going to introduce like safe call for errors and double bank as well. And last but not least is that we want to keep the type system sane and polynomial. So this feature, because again, not a proper union type, it doesn't introduce any exponential like algorithm to the compiler. So the compilation time won't take like minutes at some point. It happens like in other programming languages. And if we take a look at the other like programming language ecosystems, we can basically see those approaches. The first one, which dominates in programming languages that are less statically typed or prefer to use structured typing, is called like, we call it like two-value returns, and it's like common in such languages as Go, Lua, Julia. When you just return a tuple, the first one like it's a proper value, and the second one like it's like some error code. Also, JavaScript recently introduced a try operator that basically is doing the same. In programming languages that, on the other hand, they like types and prefer to do everything like statically typed as possible, like things like with special wrapped value and shortcuts dominates. Like in Rust, there's like result plus some shortcuts with like question sign. In Swift, we have like again result and like a bunch of like try and catch operators that help to work with your result type. And also, there is like an experimental programming language, Zeek, which is quite popular nowadays. And what's interesting is that they also use error union types. And it was quite interesting because when we understood that there's a possibility of using union types specifically for errors, we thought that, oh, well, we are going to be one of the first ones, but of course not. As usual, there's like a programming language that is already doing the things that you would love to do. But it's nice because like in Zeek, it's while it's still like an experimental, it's proved to be like quite convenient. And they use basically the same. They have like error union types, so you can return a type and a bunch of errors, which like act as a tags. And one of the important things is that in all those cases, like people do not use exceptions. Well, they use exceptions or panics, but specifically for unrecoverable situations. But when you want to handle error, all like those approaches, they use just values, and errors like act as a values. And so let's dive into like actual design of the feature. So first of all, like we introduce this new error modifier, now it will be possible to use it like in front of like your object or a class, and it doesn't change anything like how you work with your class. So you can still have some metadata. So if you want to like to create an error that holds like invalid character, like diagnostic message or offset, you just use like your like regular properties and put the information in it. And speaking of the Zig programming language, if you take a look at their like GitHub issue tracker, there's like one of the most upvoted issues is to allow using this additional metadata together with errors, because in their design you can use like errors just as tags. They cannot like carry additional metadata. But unfortunately, it was closed as not planned because of their other features that contradicts this behavior, mostly with like life cycle problems. So here, like, we are still not completely as a Zig. However, I mentioned good part, but the bad part about this error modifier is that it actually restricts how you can define your class. And first of all errors have to be final. And that's one of the main limitations that we have. And also, it's an error, it cannot have like a generic. And the reason for that is that, again, to keep our type system polynomial insane, because when we have like union types and generics, it might become increasingly hard for the compiler to infer actual types. So you might think that it's like quite like a limitation that I cannot create an error class that was open. And previously I showed like a bunch of slides where like I used like shield hierarchies. And if my errors are all final, I cannot do that. And that's true. But in the first iteration, we believe that if you want to like compound like a bunch of errors, like you can use just a type ls. It will work the same as with like shield hierarchies. Absolutely. So if we used to have such a shield hierarchy when we have like a fetching result, again, when we have like a data class success and then a bunch of errors, so what happens with the rich errors? Like, first of all, we forget completely about the success because it's just an unused class. It's like, it's there just to like hold some data, and it doesn't bring any valuable, like any benefits to your code. So we just now start thinking about only errors. And we create a bunch of like error objects and classes. And for a compound type, we just like use a type ls that holds all those types all together. And now when we return we have a function like fetch data, we can, again, we do not use any success, we just return actual data or a bunch of errors if needed. And that's it. The next design principle is that all those errors, they have to live in a separate hierarchy. So like we have to categorize our errors somehow specially, which means that errors are not subtype of any question mark. So if you have like an error or like an instance of like an error object, you cannot pass it to a function that expects any type. And the same happens actually with the generics. If you have like a generic that is bounded with like any question mark, you cannot instantiate it with an error. And again, it's because like we believe that it's still important, and we have like a few use cases where it's needed. We of course will have like an error like top type, which can be used like as an alternative for your any question mark. And if you want to like write a generic code with errors, you just can use like bound your generic with an error type and work with it all together like as previously. The next thing is about like this new syntax for declaring disjoint union types. So I mentioned that this feature not a union type, but more acts like as having like a main actor and a bunch of errors. So it's possible to declare like a type int or a bunch of errors, like here like int or a duplicate ID error or parsing error. We can also declare just like 2 errors, but we cannot declare like again int or string. It's prohibited by the type system and doesn't going to work. So basically what you are trying to achieve here is to make this error union type truly disjoint, because having like errors in a separate hierarchy means that now we have like int or error where we can always like separate this type together. Because if we instantiate a generic with such a type, we always can say that int is a regular type and error just lives in a separate hierarchy, and do type checking. And because errors are final, it allows us to do a disjoint union for errors as well. So if you take a look like at the updated type hierarchy for errors for a Kotlin type system, it looks like this. At the top type, you have any question mark or error, and any can be a subtype of such type, as well as like my error. Like my class can be a subtype of any, but not of my error, and vice versa. And nothing still is a bottom type of the Kotlin type system hierarchy. And what it actually gives us, like, except that we like covered the original case. First of all, we can use the feature, so this feature called in-place tags. Because, for instance, if we have a function last that is declared in our standard library and can be similar for any other container, it looks like this. We have to like remember that sequences actually can also work with nullable types. And so that in order to find the last element, first of all, we have to introduce a new Boolean property. Then when we go through the elements, remember that they find the property. And if you didn't find that, do something like throw an exception or do something else. And at the end, we have to check to cast our variable to a non-null variant. And that happens because there's not enough like types in our type system. And with errors, it's going to be like very easy. Like we just use an error object not found. We use like our last element as not found. And if you find an element, we just reassign it. And then again, smart casts help us to eliminate like all the unnecessary check casts. And of course, this feature is actually a more generic one. Because also one thing that is missing in Kotlin on purpose is some sort of like optional values. Well, in like in many programming languages, we have like result, but also we have like optionals. We have like in Java, we have like in Swift, we have option in Rust. We have like maybe monad in Haskell. In Zig, we have like also optional values, and so on. And in Kotlin, we used to have just nullable types if you want to signal that there might be a missing value. And it works unless you use, again, a container with nullable values. Because, for instance, if I have like my list of null and 42 and I invoke this function first or null, the result is null. But what is the semantics of these functions? Does it mean that the collection is empty, or it's actually just the first element? Well, we don't know. And it might be a bit better just to return like some sort of like optional. And because, again, rich errors, they live in a separate hierarchy, we can now distinct these two values and say that a regular optional in other programming languages is just like an error union type in Kotlin. And for instance, function first or first error could be now defined just like that returns T or not found. And now we do not have like this ambiguity between nullable types or something else that we contain in our list. Next one is about shortcuts and chain calls. So here I just want to like quickly to repeat how it works with nullable types. So if we have like this expr_a.expr_b.expr_c, so what happens when we use like save call operator? First of all, like expr_a has type like type A question mark. The expr_a.expr_b now has the type of expr_b, nullable type, and this null can come from expr_a or from expr_b. And the whole expression now has the type of type C plus null, which can come from expr_a or from expr_b or from expr_c. Now, what happens with rich errors? because here we want to use this trick and reuse the same operator. And again, x per a is just like, as previously, just type a or error 1. And x per a and x per b now has this type b, and previously we had this null from first or the second. Now we have error from the first or from the second expression. And the whole expression now has this type C or E1 or E2 or E3, and so on. And this is how it's going to work. And again, this is like the main actor, and we can use its functionality. Because again, if we had just proper union types, like A or B, and I have like method foo and method bar, my question is like, which methods I can access in a type-safe manner here? And the answer is actually like, it's quite set, like just methods, only methods from their common supertype, any, which like toString equals and hash code, which is not that useful. And that happens with any like union type that is like written like result, either, or modifier. I can use only method and functionality from their types, but not from the underlying types, which are like more useful in my case. And with rich errors, I can use like built-in support and easily access method foos, bars, and so on. The next operator is that we have for nullable types is double bank. And what happens when we have a nullable type and invoke a double bank on such? We have a null pointer exceptions. And a similar situation is going to happen with rich errors. If we have a rich error, we just replace this double bank with .throw method, which can invoke like can throw a specific exception. By default, it will throw something like Kotlin exception and will tell the user that it's like a not found object. But also, it will be possible to override this throw operator if you want to throw like a specific exception in your case. So very easy. It's a little bit harder with Elvis because in our design we do not want to provide any Elvis operator. Like today we have this Elvis operator for nullable types, but the problem with errors is that on the right-hand side of the Elvis, I would love to have my error object because I would love to like process these errors somehow. And if we introduce Elvis operator for rich errors, it's quite possible that people will forget to handle these errors like sometimes. But it's actually not that a problem in Kotlin because errors, they are just values, right? And we can write like an Elvis kind of function ourselves, which might look like this. It's an inline function, and the extension receiver, it takes T or E. E is bounded with an error, so it's fine. And we have like a lambda like default that takes like, it's like from E to T. And if this receiver is error, then we invoke this lambda, otherwise no. And what does it mean? So that means that if I have an expression that is of the type like type or error, I can invoke this function and make like a non-local return. Because it's an inline function, that's fine. But also if I want to actually get full information about errors, I can also take this E that is in my lambda and then process it and again get all the exhaustive information about the potential errors. So we get like nice things from both of the worlds. And again, but what about exceptions? So we do not have checked exceptions for a purpose. And we really trying to draw this line that people have to use exceptions only for unrecoverable cases. But sometimes, of course, you have to use exceptions because some frameworks throw exceptions, and maybe you, as a framework vendor, would love to catch all the exceptions that were thrown by a user, just in order not to like shut down your server and so on. And if you want to work with, sorry, wrong slide. This one is correct. If you want to like work with exceptions in like Kotlin-friendly way, we can like introduce and we'll introduce a function like runCatching that exists today for Kotlin result. And again, but this time, this function will wrap an exception and return like as a error union type, which means that now if you have like some API in like in Java or in Kotlin or somewhere else that throws an exception, and you do not want to like work with it as an exception, but rather that with just regular errors, it's relatively easy to turn this method into like one that returns, again, a main actor like list of string or a throwable error. So it's to sum up. So rich errors, it's a new language feature that is developing today in Kotlin, and it's designed to handle recoverable error cases. And exceptions are going to be used for everything else, for unrecoverable ones. On the one hand, this feature like it generalized like this nulls as errors pattern, including like all the ergonomics of nullable types, like safe call and double bank. On the other hand, it's built-in support for patterns around like result, optional, maybe, try, either, and so on. And it's in progress, and you can expect keeps like with the proper design explanation and how it works under the hood, what are the compilation strategies of it, like soon, and I think this month, or like definitely this summer. And that's it from my side. Thank you. I think we have like time for 1 or 2 questions. But anyway, I'm going to be at this like language design booth, so you can like catch me and ask any questions, even not related to rich errors, but just about everything in the language.
So one question about the return types, about the errors. So you didn't mention if we have to mention these errors explicitly, or if maybe the compiler can just add that type for us automatically. So how is that going?
Sorry, could you repeat? I couldn't hear. Yeah.
So do we have to define all the errors for the types, or can it be that Kotlin can infer the error types as well from the function execution, for example?
Yeah, so that's one of the things that is happening sometimes in Zeek. So they're trying to infer like errors like from the bodies, and you can just say that it returns int or error. Today we are not planning to do so, but we'll see how it goes. It's definitely to say that just my function returns like again int or error, but at the call side the compiler won't be able to understand like the exhaustive set, so you have just to use like custom error types at the call side.
Okay, thanks.
Hello, thank you very much for the presentation. I have seen error objects and error classes, but what about error enums? Maybe they could be useful to declare subtypes of, for example, network error.
Yeah, so for now we are trying to not to add error enums, but we see that there is a use case when we actually want to use like some kind of sealed hierarchy, which means that basically error enum. So it's possible that at some point we'll add them, but we see how it goes, whether we need it actually or not.
Okay, thank you.
Hi. I was curious about Java interop. How does the method's signature end up looking from Java?
Yeah, it's a good question, and the answer is not that good. So for now, to make it like very efficient, we want to compile it just as a Java-like object. But we are thinking of compile a plugin that can turn this, can provide a separate signature with, for instance, like optional or a result class that actually handles this. So for Java like API, it's still like you can invoke a method, but it will return a result. Or like, and for Java, there will be some cost, like some overhead, like at runtime, but not for Kotlin call sites.
Thanks.
Hi. So is result going to be deprecated? And if not, what are its valid usage once union types for error makes it into the language?
Yeah, Kotlin result isn't going to be deprecated, but we believe that the usages of Kotlin results are going to be reduced, that's true. But it's not going to be deprecated. The problem with Kotlin result is that at some point we decided to make it as strict as possible, so it contains only one generic. It doesn't contain like the second one for errors, which happens usually like in other programming languages. And it's again for a reason. It has its usages for Kotlin X coroutines and some usages besides this, but we believe that this case with rich errors will actually be more beneficial for users. But again, we do not plan to deprecate it, but we think that rich errors can be more useful when you want to use like Kotlin result.
Thank you.
Yeah, I think that that's it. Thank you very much for your attention. And again, I'm going to be there.
Morning.